In this video, we will learn to solve logarithmic and exponential equations. Here are the steps to solving logarithmic equations. Number 1, isolate the logarithm. If necessary, write as a single logarithmic expression, then write as an exponential equation in the form of b to the a equals to u. And if we have a form log of a equals to log of b, where you have a log on both sides, then simply set a equals to b. Step 4, solve. So let's go through some examples. Example number 1. We have log base 3 of x minus 5 equals to 4. Now before we even get to that, let's take a look at x plus 5 equals to 8, something simple. The reason we subtract 5 is because the inverse of addition is subtraction, and we get x equals to 3. If we have 5x equals to 15, we divide by 5 because the inverse of multiplication is division, and we get x equals to 3. Similarly, the inverse of a logarithm is an exponent. So logs and exponents, these are inverses of each other. So just like the inverse of adding is subtracting, inverse of multiplying is dividing, the inverse of a logarithm is an exponent and vice versa. So to solve a logarithmic equation, we need to take its inverse, which is an exponential equation. So we take 3, which is the base of the log, to the 4th power equals to x minus 5. We convert this to an exponential equation using the rules from our previous video. 3 to the 4th power, this is equal to 81. So we got 81 equals to x minus 5. We add 5 to both sides, and we get x equals to 86. I'm not going to do this every time, but we can check our answer if we wanted to. We take our 86, we plug it back in, so we have log base 3 of 86 minus 5. 86 minus 5, this is 81, so we have log base 3 of 81. And log base 3 of 81, if we use the change of base formula, this equals to log of 81 divided by log of 3. If you put this in a calculator, you will get 4, which is what we should have gotten. So this is the correct solution. Next example. We have 2 times the natural log of 3x minus 2 minus 18 equals to 0. Step 1, isolate the logarithm. So we're going to add 18 to both sides. This gives us 2 times the natural log of 3x minus 2 is equal to 18. Then we divide both sides by 2. So we get the natural log of 3x minus 2 is equal to 9. And now we have to convert this into an exponential equation. But why? Because the inverse of a log is an exponent, and we use an inverse to solve an equation. But recall that natural log is actually log with base e of 3x minus 2 equals to 9. So you could either rewrite it like this, or simply recall that the base of a natural log is equal to e. So to write this as an exponential equation, we have e to the 9th power equals to 3x minus 2. Now, e to the 9th power, you can put this in a calculator, or we can simply solve for x. So we're going to add 2 to both sides. Then we have e to the 9th plus 2 equals to 3x. And then we divide everything by 3. So we're going to get e to the 9th plus 2 all over 3 equals to x. You can put this in a calculator or on decimals just the way it stands, and we will get our answer is x equals to 2701.6946. So actually put this in a calculator or into decimals, make sure that we get the same thing. Next, we have log base 2 of x plus 4 plus log base 2 of x equals to 5. First, isolate the logarithm, so all the logarithms are on one side. We're good with that. Second step, write as a single logarithmic expression. Before we can take an exponent of the logarithm, we need to write this logarithm on the left side as one log and not two separate logs. So we have log base 2. And remember that anything with the positive sign goes on the numerator. So we have log base 2 of x plus 4, and then the x also goes on the numerator because it's a positive sign. So we have log base 2 of x plus 4 times x, and that equals to 5. Another way to think about it is if we add two separate logarithms and you combine them to one log, the addition goes to multiplication. Now that we have a single logarithm, we rewrite this as an exponential equation. So the base of the log becomes the base of the exponent, the 5 becomes the exponent, and this equals to x plus 4 times x. 2 to the 5th is equal to 32. That equals to x squared plus 4x. To solve any quadratic equation, all terms must be on one side, so we subtract 32 from both sides. And this gives us 0 equals to x squared plus 4x minus 32. We could use a quadratic formula, but it's easier to factor this. So we get 0 equals to x plus 8 times x minus 4. And by the zero product property, we get that x equals to negative 8 or x equals to positive 4. Now, you may recall from college algebra or even intermediate algebra that logarithms cannot be negative. The domain of a logarithm is greater than 0. So because we can't have the logarithm of a negative number, we have to discard the solution, and our only solution is x equals to 4. Another example. We have log of x plus 10 equals to log of 11 plus log x. So first off, let's rewrite this as a single logarithm. So we have log of x plus 10. When you have multiplication, when you have addition of two separate logarithms, and you write that as a single logarithm, from two separate to a single logarithm, the addition goes to multiplication. So this gives us 11x. So on the left side, we have log of x plus 10. On the right side, we have log of 11x. If these two sides are going to be equal, then x plus 10 must equal to 11x. So we subtract x from each side. This gives us 10 equals to 10x. We divide both sides by 10, and we get x equals to 1. Next, we talk about solving exponential equations. So steps are isolate the exponent. If necessary, write as a single exponential expression. Then this step is a little bit different. We take the natural log of each side, and we'll talk about why later on. And then at the end, we solve. So let's go through our steps. Step 1, isolate the exponent, which means we are going to add 8 to both sides. So we have 9 to the x equals to 38. Step 2, if necessary, write as a single exponential expression. We don't have to do that step because we already have a single exponential expression. Step 3, take the natural log of each side. So we take the natural log of the left side and the natural log of the right side. Here's why we do this. When we take the log or natural log, the exponent is going to come to the front. And since we are solving for x, we want the x to not be an exponent, but rather to become a coefficient. So we bring this to the front. And now it becomes x times the natural log of 9 equals to natural log of 38. So look what we did. We took the variable, which was an exponent, making it impossible to solve, and we made this into a coefficient. And we turned this into a multiplication problem. So the inverse of multiplying is dividing, so we divide both sides by natural log of 9. So we're going to get x equals to the natural log of 38 over the natural log of 9. Put this in a calculator, and we will get this equals to 1.6555. If we wanted to, we could check the answer. Take this and plug it back in. So we have 9 raised to the 1.6555 minus 8. We want to check, does that in fact equal to 30? So when you simplify the left side, put this in decimals or a calculator or whatever, we get like 29.999. And that's not exact because we rounded this exponent, but it's about 30, so we know we did it correctly. Okay, next we have e to the 2x minus 3 is equal to 7. So let me rewrite that. E to the 2x minus 3 equals to 7. Step 1, isolate the exponents, already isolated. If necessary, write as a single exponential expression, which we don't have to, it's already single. Now, step 3, we take the natural log of each side. And when we do that, the exponent is going to come to the front. So we have 2x minus 3 times natural log of e equals to the natural log of 7. ln e, the natural log of e is equal to 1. So remember that, natural log of e is equal to 1. Why? Because remember, natural log is log with base e. So this is saying log base e of e, and we learned that property that if you have the same base and the term that you take the log over the same, then that equals to 1. So ln e is equal to 1. So we get 2x minus 3 equals to the natural log of 7. If we solve for x, we're going to add 3 divided by 2. X equals to the natural log of 7 plus 3, all divided by 2. And you can put this in a calculator. When you do that, you are going to get 2.4730.